Hello, my name is Toby and I'm head of global customer service at DE-CIX. I'm also the moderator for this breakout session. I'd like to introduce to you our next speaker for breakout session number 4, which is Annika Wickert, second chair of Freie Netze München from the Freifunker Association. And today Annika will give us insights into flow monitoring explained, from packet capture to data analysis, the use of IPFIX exporter. So Annika, the stage is yours. Enjoy.
Thank you. Yeah, welcome to my talk, Flow Monitoring Explained. It's a short overview of how you can use flow monitoring, how it's configured on DE-CIX, and just which tools you can use to actually leverage the data. I'm sorry for the noise in the background, maybe because there's a large thunderstorm, and if I run out of the out of my room, then I'm trying to catch my dishi because it tries to fly away at the moment. So who am I? I'm Annika Wickert. I'm the second chair of board of Freie Netze München. I'm also a senior network engineer for a larger open source company. My Twitter handle is at AWLNX, and my GitHub handle is the same, but the N is missing because it was not available anymore. So what's Freie Netze München? What's FFMUC? It's an open community network which does Wi-Fi, and we do also some stuff like FFmeet, which is a free video conferencing system, and which also needs good peering because, you know, video needs good connections, and that's why we are also deep into peering now. We also run some other privacy-related services like DOH, DOT, DNS script, and DNS, and a little streaming service, but that's just for us. The preface is we moved recently, last year in November, I think we moved to our own ASN. And I have now two data centers. We announced 2/48's IP and 2/42's 24's legacy IP at the moment, which maybe grow in the future. We have some RIP and FIP limitations because, as I said, we are non-profit thing, and thus we have not that much money and need to leverage the resources we have. DE-CIX offers us remote peering in Frankfurt and in Munich, which we use. The motivation for all this IPFIX stuff was basically, or for all the peering stuff was basically, we peer with the route service, of course, and it has many routes, but some prefixes are still missing. And we filter prefixes because, as I said before, we are quite limited on FIP and RIP sizes. So we try to only let routes in our FIP which are really needed, which makes it a bit harder for all the processes. Root servers are generally stable at DE-CIX, so this is not really an issue for us, but we still like direct peerings because it's a factor to have the routes more stable. And of course, we are nerds and we want to play with stuff, so that also comes into a factor. But we needed to know, as I said, limited sizes of FIP and RAM. Where is our traffic going? Whom should we pair with? What is going on in our network? So the setup at the moment is basically like this. We have our servers in Munich, which are connected to via remote peering to DE-CIX Frankfurt and directly to DE-CIX Munich. Pretty standard setup here. Then how does the IPFIX ingest work? We enable the IPFIX exporter in the DE-CIX portal, basically, which then starts the IPFIX export, sends us everything where UDP DTLS encrypted to our endpoint in Munich, which is then extracted there by the UDP DTLS wrapper, which is open source by DE-CIX. We then feed it to Unified Flow Collector, which is part of ElastiFlow, and basically takes the flow and puts it into Elasticsearch, and also is responsible for all the fancy graphics we see later on. So what is IPFIX? It's IP flow information export. It's basically sampled information about traffic flows, can be transported via SCTP, UDP, and TCP. As you can see, it contains various fields about the flow information, like source destination MAC, source destination IP, which protocol was used, how many bytes were exchanged, even which TCP flags were used. So for debugging, it's also great stuff. Do I see more fins? Do I see more resets? Whatever. You can basically debug many things with it. Now to the IPFIX export at DE-CIX. Basically, it's generated by the DE-CIX platform and sent to a destination IP, which doesn't need to be on the DE-CIX. You can send it everywhere. The sampling rate is 1000 to 1, which is important. I didn't find this information at first and had weird graphs, so that's the sampling rate used. It's encapsulated in DTLS because the flows would otherwise maybe expose a privacy risk because as I said, there are IPs in it, and you don't want maybe to let everyone on the path know who exchanges data in your network with whom. The encryption is a pretty lightweight daemon, which you just run on your endpoint. I made some pull requests for it, or one pull request for it, to make it a bit more flexible, because it was just sending to one fixed IP and just to a one fixed port. So that's now configurable. And to enable it in the DE-CIX portal, it's basically just put in your IP, select the port from which you want to export it, and there you go. Yeah, about ElastiFlow. We use ElastiFlow basically because it was the first platform which I knew from the past. I used it in previous companies already to display my flow data. It's pretty easy to set up, especially nowadays that it just has a Docker Compose. And the pretty neat thing at the moment, which I prefer it the most, is that it just enriches everything with geo IP data. So even if I have not all information in my RIP or FIP, I just can enhance it with geo IP feeds. And I can also leverage some thread information from other sources, which is kind of cool. So you don't have to do everything on the switch. And it also ingests with there's a unified flow collector, it's the new flow collector. It can just do IPFIX, NetFlow, and SFlow without especially configuring it for each other. It's just the same port. You just send SFlow, IPFIX, NetFlow, or whatever to it, and it automatically works. If the data templates also provide the sampling rate, then even this is detected automatically, and you just get the correct scaling and everything in your dashboards, which is pretty nice. But some vendors miss those data templates and don't provide the sample rate used. So sometimes you have to configure it manually. But even this works together with, for some exporters, you can just say a fixed rate, and others are still auto-detected. So that's kind of really, really nice. Also, the pre-built dashboards are a really good thing, because you don't have to get it up and running for a non-profit. I don't want to fiddle with ages to configure Grafana or whatever. I just want to look into my dashboard, and it should just work. Soon there will be a feature which we wait for and which we tested. You can then obfuscate your prefixes. Basically, we say, I don't want to know which exact IPv6 from my prefix did what, as a privacy enhancement, because as Freifunk, I don't really care about the individual IP, but I want to know what my network does. So I don't care if this specific IP watches Netflix the whole day. It's just not important for me. I just want to know someone watches Netflix, and maybe it's good to have a peering there. So this will be obfuscated soon, down to the prefix or to prefixes you want to enable, like do only /64s or do 56, whatever you want, which is also, as I said, good for privacy and makes it easier for us to use it. Also, it will be already done on the flow collector, so the data basically never ends up in your Elasticsearch. ElastiFlow also offers commercial support, but there's also a very, very active Slack community where you could just put in your questions and there you go. And basically I never had a time where nobody was around and couldn't answer your questions. It's just insane how helpful also the people are there. A few graphs. As you can see, that's the basic, that's the starting point at ElastiFlow. You see some figures about how much traffic we exchange with each individual network. You get it divided by client and server AS. So you can basically see with whom we exchange most of the traffic. Of course, compared to big service providers, that's not that much, but I think for small non-profits, it's already quite interesting. What we did with this data is I wrote a little shell script which basically queries the Elasticsearch, gives me the top 10 or top 20 of all the ASNs we exchange traffic with, and connects to the eAPI of our Arista switches, looks which peerings do we already have, and just spits out the peerings we need to do. Also already in Arista config format, so it's basically just copy paste. At some point I might open source this, but it's a kind of ugly still, so not ready for production, I would say. It's good enough for us, but no error handling and so on. That's also what you get. You get a breakdown of what clients exchanged and how much traffic it was. As I said, as soon as you enable the obfuscation of prefixes, that's only individual prefixes and not... so for us, 1/64 is one segment, so-called segment, which is just a part of the town. And so you can see which part of the town basically exchanges the most traffic. So we can either break it down to a smaller segment or whatever we want to do with this information. It's just interesting for us to do some capacity planning and maybe add more servers or more endpoints and so on. We also see which protocols are used the most and so on. Also IP versions and stuff. And yes, there is more IPv6 than IPv4 in our network. There are also these nice datagrams where you can actually see how much data is exchanged and with whom we do the most traffic, which is also kind of interesting because you just have it in one go. You don't need to figure it out with some extensive queries or whatnot. You just enter the time frame, say, give me for the last 7 days this graph, and it will just automatically turn up. So with all these informations, as you can see, we are now able to make better peering decisions. As I said, we are quite limited on resources, so I cannot just turn up everyone as a peer because then our switches sadly don't have enough RAM and start a reboot cycle. So we just turn on peerings for networks we really know. As you can see or saw in all the graphs, no surprise, mostly eyeball networks, cloud providers, and CDNs. But with those informations, we were able to set up all the sessions, which is kind of nice. So we basically exchange traffic most of the time now via direct peerings. And everyone we have via route servers, this is also a backup if needed. The resources used for this is basically this DTLS IPFIX wrapper, which is later maybe even integrated, or ElastiFlow looks into integrating the DTLS wrapper directly into unified flow exporter. So you maybe don't need this step anymore. We will keep it anyway because our ElastiFlow runs on a different host, which has no public IP than ElastiFlow. ElastiFlow is only reachable via our Nebula network internally, so we don't want to expose it to the outside world. So we maybe keep this DTLS IPFIX wrapper anyway. At the moment in our network, it runs on a Raspberry Pi, so it's really, really low on resources if you don't push too much traffic to it. I think it's only like 0.5 of a core, or not even that. 0.5% of a core, so it's really not that much. You can just run it basically everywhere. If I want to take a look at ElastiFlow, you can just go to elastiflow.com. There's everything it's explained. Just be aware there are at the moment 2 versions, the old version 3 with Logstash as a flow importer, and the new version, I think it's version 5, but not really sure. So use the new approach with the unified flow collector. It will save you much resources. I think we went down from using 8 cores to ingest everything into Elasticsearch with Elasticsearch running down to 2 cores or something. So everything I can tell you, please use the unified flow director. It's really a good thing. That's it basically for my talk already. It's a short overview of how we use IPFIX and why we use it. As I said, we use it also mainly as a second approach because our switches cannot handle so much requests and don't have so much memory. Also, if you peer with, let's say, a Linux box or something, it's way easier to just enable IPFIX on DE-CIX than get everything out with IP tables and stuff. So this is a really cool feature, I think, also for sanity checks. Do we really see on our switches the same as we see on DE-CIX and so on? Yeah.
Thank you, Annika, for all the insights you have given us and for the beautiful pictures you showed us, how you measure the graphs and where traffic flows. There's some commentary from the community, from Leonard, who says, this is actually not a question, but he has to say that that kind of non-profit networking is really interesting. And by the way, he thanks for the FFMUC Jitsi instance that was built or spawned. He really likes that. And he has also a question for DE-CIX. Maybe allowing the exporter already to remove the last octets from the addresses for privacy. This is something I will definitely note down and take with me into the next meetings regarding the IPFIX. And one more thing which I like to ask you from my side is, when you started with it, when you said, okay, we want to do some measurements, where do we start off? What do we want to know? Which software do we need? How long or how much time consumed that process? Also, how long did it take until you really had that all in place and could view the data?
I think, as I said, I knew ElastiFlow already, so that was kind of set for me that we use ElastiFlow. So the only thing which I needed to figure out was how to get IPFIX or SFlow or something out. But I saw this, I think it was an announcement on the mailing list or something that DE-CIX now has IPFIX export. So I was like, hit the button, log in and try it. So as soon basically as this was announced, I was like, okay, let's try.
Yeah, sounds great. So we could help you in this regard. And if you have feedback for us, what we can in future improve, like for example the last octets that was mentioned from Leonard here, we are always open for that and love to take this into discussion. So do you actually plan to extend it, or do you say that's it, that's what we wanted, or is it planned to extend it in any way?
Well, there's always a plan to automate it more. So basically, what I want to have in the end is when a new top talker pops up, which we didn't see before, then it should automatically create the peering or send out a peering request. If it comes back, then set up the session, and here we go. So I would like to have it as much on autopilot as possible. Also notify me if peerings are gone. For example, this should also be a feature, like people don't talk with us anymore over DE-CIX or whatever, then please send me an email so I can save the RAM on my router. As I said, we are pretty RAM constrained here. But it's also a very neat challenge, to be honest, to work with these low kind of RAM situations and use all the tools available to work around it.
Yeah. Also, I found it interesting that you said, okay, I could have done it in this way, but this would have been Grafana, much more complicated or time consuming. But here I just had a data flow. I had the software on the other side, brought both together, and then I was happy with it. Sounds good to me too. And there's another question from Leonard from the community. The DE-CIX IPFIX export, does it fill in the source and destination MAC address fields?
I think I saw something that they do. I think you do, yeah. I actually had it looked up because there was some data which was missing, but this was an error on our part, and and you could then see it on the MAC addresses, yeah.
Great. So that was so far all the questions from the community that I've seen. General question, since you know how to build it, if others want to start with it, I think it's okay for them to reach out to you when they need help or assistance. Yeah, that's absolutely great. Super. And yeah, I don't see any more questions or commentary from the community. So at this point, I would say thanks a lot for showing it all to us. And yeah, enjoy the rest of the tech meeting. We have some more surprises to come. Thank you very much.